Hi, pre-algebra students. So in today's lesson 9.4, we're going to talk about choosing an appropriate data display. So in the key idea, you're going to see lots of different types of graphs that you've learned about over probably over the course of all of your middle school math classes. And we're going to be talking about the different types of graphs, what they are used for, and when it's best to choose that type of graph to represent data. So we're going to start with a pictograph, and a pictograph is, of course, a graph that uses pictures. So it's when you want to create a nice visual display of your data, you're going to use a pictograph. A bar graph is a graph that is used to show data in specific categories. So for example, if you are taking a survey of your friends and what their favorite type of ice cream is, you could use a bar graph to represent the number of people that like vanilla or chocolate or strawberry. Please note that in a bar graph, the bars do not touch, and each bar represents one specific item. Okay, and our next graph is a circle graph. And of course, a circle graph shows parts of a whole, and probably a big key idea here is a circle graph is used when you want to represent things with percents. So don't forget, that's a key idea. So like, let's say you want to know what percent of students play a certain sport, like soccer. What percentage of eighth graders play soccer? What percentage of eighth graders play volleyball? What percentage of eighth graders play basketball? And so on. You could use that in a circle graph. A line graph is a graph that shows data change over time. So for example, if I want to know the sales of a company from over the course of a year, over the course of several years, that would be best represented in a line graph. A histograph, sorry, not a histograph, a histogram is a graph that shows frequencies of data values, and the key here is that we're using intervals of the same size. So for example, if I'm measuring height of students and I want to know how many students are between 50 and 54 inches tall, how many students are between 55 and 59 inches tall, how many students are between 60 and 64 inches tall. So intervals have to be exactly the same size. And notice in this graph that it does use bars, but in a histogram, the bars touch, unlike in a bar graph. So that's an important distinction to make there as well. Okay, and then we have a stem and leaf plot. So in a stem and leaf plot, it's orders numerical data. So the nice part is data is ordered from least to greatest here. And then it shows how the data is distributed. And the key in a stem and leaf plot is that these numbers on the left, your stems are the digits in the ones place. In the tens place. And then these digits on the right are the digits in your ones place. So for example, a lot of times when you see these, you'll see a key. So it might say like 4/6 is 46. So you know how to read that. So these numbers in the first row, like this is 10, 12, 13, 16, and so on, so that you can read that. And then it's real easy to count the pieces of data here. You just add up your leaves, and that tells you the number of pieces of data. Also, notice that this graph is only appropriate if you are representing data in the tens. Like once you start getting bigger numbers, you can't use a stem and leaf plot. So next we have our box and whisker plot, and that is used to show variability of data that's used. You want to organize into quartiles, so into fourths. Okay, so it separates into, you have a lower quartile. So first quartile, a second quartile, a third quartile, and a fourth quartile. So this is called your box. These are called your whiskers on each end. And then each part of that graph represents 25% of the data. A dot plot shows the number of times each value data set occurs. So again, this is really good when you have small numbers, kind of like a stem and leaf plot in your set of data. And then each dot just represents a piece of data. So imagine if this was like the numbers, 1, 2, 3, 4, 5, 6, 7, 8, you could see like, there are 3 pieces of data for the number 3, 2 pieces for 1, and so on. And then I don't know what happened here to my notes, but you can see better in your note packet. This is a scatter plot. And of course, the key word there that you should remember is this word relationship. So it's showing a relationship, and of course, also keyword two, relationship between two things. Are these two things related? That's how we use the scatter plot. All right. Okay, so let's take a look at example one. So in this one, it says, choose the appropriate data display for each situation and explain your reasoning. So what you want to do here is look for some keywords. So in this one, it says the number of students in marching band each year. So I would say for this set of data, the best way to represent this piece of data, whoops, be a line. And the key here, our reasoning is because we're showing change over time. So again, if I want to show how many students were in band in 2016 and 2017 and 2018, a line graph would best represent that data. Please remember, in a line graph, unlike a scatter plot, the lines are connected, but in a scatter plot, we do not connect points. Okay, in the next example here, part B, we want to show a comparison of shoe sizes to their heights. Okay, so even though that word is not used, here we're looking to see, is there a relationship between shoe size and height? So between two things, between, and I'm going to say two sets of data. So remember, when you want to show a relationship between two sets of data, your best bet for that is to use a scatter plot. And again, unlike the graph above, we would not connect those points. Okay, so let's see how well you do with these two examples. Pause if you need to, complete the on your own, and I'm going to keep moving forward. So we're going to go to example number 2, identifying an appropriate data display. So here you have a set of data that's represented kind of in this little spiral notebook here. So you've collected the number of hits for your school's new website over the course of 5 months, and you want to display this in a set of data. So we have 3 choices here. We have this first one, which is clearly a bar graph. In example A, in example B, we have a histogram. We're showing intervals. So notice here the bars do not touch, but here the bars do. And then in the last one, we have a line graph. So I would say, first of all, looking at the first graph, it does seem to represent the data appropriately. So this is an appropriate representation of data. Okay, so in this case, because it does appropriately represent the data and it shows the number of hits each month, this bar graph would be an appropriate representation. In example B for the histogram, even though the intervals are separated into equal parts, I would say this is not an appropriate representation of data. And mainly because it doesn't show, we're not able to see the number of hits for each month. So even though it does include the data, you can't see the number of hits. Okay, and then in this last one, this is a line graph, and this is, of course, also an appropriate, an appropriate representation of data because it does show the change over time. Okay, so I think you're going to have a question that you need to stop and answer, and then we're going to go ahead and move on to question number 3. So in this case, we're going to talk about something new. So when are graphs misleading? So you have 2 graphs here. Both of them are line graphs, and both of them are representing data over time. So they are a correct representation of the data, but one of them is misleading. So we need to look at both graphs and determine why. Okay, so if you look at these 2 graphs, this graph, and I know we did talk about this in some previous lessons, this is called a broken scale. And what happens when you have the broken scale is that it does make the data misleading because it's exaggerating these increases and decreases in the data. So by taking out this this lower section in the graph where there is no data, it almost stretches out that line and makes it look like those increases and decreases are much more dramatic than they actually are if you use an accurate representation of the scale, as you should see in the graph on the right. So the key is that if you're not looking at the scale over here and you're just looking at the line, it can definitely look very misleading by just looking at the visual part of the graph. Okay, so we've added an appropriate written response for the answer to this question. And remember, explain means to write an answer in words. So you do need to write a little bit more for these responses in this section. So we're going to look at example 4. And this one is kind of long too, so I already went ahead and put my response in. So as a volunteer concludes that the number of canned foods and boxes donated were about the same, is this accurate? And I said no, because the boxes are bigger than the cans, so it looks like the same amount. But if you look at the key, each one is worth 20. So if you count up the cans, there's a total of 220 canned foods, but only 120 boxed foods, which is almost half as much. So again, you have to pay attention to the key or the interval that's being used in the graph so that you can accurately get a picture of the data and not just look at the visual part of the graph. Okay, so there was the bell. I guess that means we are finished. So finish the on your owns, and we'll see you tomorrow.